Hello, thank you, sir.
I welcome all the dear participants for this first day of faculty development program on AI advances in mechanical engineering. Its second session is going to start now. We are fortunate to have today for this second session with us Dr. Ganesh Soni sir. Welcome sir. Thank you for accepting our invitation and sharing your expertise with all the faculty members who are there as a participant to this 1 week faculty development program on artificial intelligence advances, particularly in the field of mechanical engineering. We are really fortunate to have a personality like you, Dr. Ganesh Soni sir. I would like to briefly introduce him. Dr. Ganesh Soni sir completed his PhD from IIT Bombay with Monash University, Australia. It was a joint program in the field of simulations. In the year 2014, he has completed his master's program from BITS Pilani in the year 2009 and bachelor's degree from VNIT Nagpur in the year 2005. He is an educator and AI researcher with vast experience of more than 13-14 years. He has academic experience also in the field of artificial intelligence and machine learning, working as a faculty in AIML related courses at University of Arkada, Finland. He is faculty of data science and artificial intelligence at JSPM University, Pune. He has contributed to many faculty development programs on various technical topics across India. He has chaired for syllabus development committees at major Indian universities. Also worked as external examiner for various subjects, master's level and PhD thesis too. His areas of expertise is AI for researchers, HR, how to use AI in the everyday life, jobs in non-IT field, AI for non-IT functions like teachers, HR, sales, interview techniques, resume writing, evolving world of cybersecurity, career management and progression, and so many others. He worked as a research supervisor at PhD level in the field of application of machine learning, simulations, SERPF composites at IIT Kharagpur, impact of carbon nanotubes on the material performance using high performance computing at IIT Dhanbad, quantum computing for machine learning for optimization problems at IIT Kharagpur. Presently, he is working as a QA manager and Scrum Master at Hexagone, Pune from the year 2015. Prior to that, he worked as a design engineer at L&T Mumbai from 2005 to 2007. He has many certifications also, like Safe Agile Scrum Master 6.0, IST QB, Advanced Tester, Test Manager, a Project Management Professional Certification, and Government Certified Career Planner. So really, we are really fortunate to have sir with us for as an expert person for this first day of the FDP. Particularly, the topic of this session would be AI in simulations. I hope that it would be very enriching experience for all the participants to gain the knowledge from Dr. Ganesh Soni sir. I welcome Dr. Ganesh Soni sir once again and thank you for accepting our invitation. Thank you all the participants for joining this program. I now request Dr. Ganesh Soni sir to start this your session. Thank you, sir. Soni sir?
Screen, let me know if you can see my screen. Do you see my screen?
Yes, sir.
Okay. So the topic is AI in simulation, the next wave of engineering innovation. Let me tell you a little bit about me. NIT Nagpur, BITS Pilani, IIT Bombay, Monash University, Australia. I'm teaching AIML courses at University of Arkeda, Finland, and some universities here in Pune as well. I'm a technical project manager at Hexagone, about 15 years of experience, and we do have hard-coded properly using AI kind of technology in two of our projects for which I'm a manager. I'm currently guiding 3 PhD students in AIML and quantum computing area. So let's deep dive. I have a hard stop at exactly 3 o'clock. So if you have questions, we must address them before that. So let's talk about the automotive design revolution. When it comes to mechanical engineering, our main focus, main industry which mechanical engineer serves is of course automotive, followed by aerospace and followed by many other industries. But automotive is our, I would say, bread and butter. Usually or earlier, any new car used to get designed and manufactured, or from concept to reality, it used to take 3 years. Any idea how much time is expected these days? In how much time a new car design is expected to be out from concept to delivery? Let me give you an example. Earlier, if you remember, Toyota or Tata, any car, used to be there, and the new next version of the car, Indiga and Indigo, if you remember, used to come after 4 to 5 years. Now, what is the cycle automotive companies are expecting? Do you have any idea? Anybody would like to contribute? Take a guess. Can I see chats here? You can chats. Okay. I see 3 months. 3 months is a bit too much, sir. In 3 months, how can you make a concept to design? 1 year, 9 months. Okay. So right now it is at 18 months, and the expectation is within 6 months they should deliver. Okay. So that is what is expected. This is good. This is good. So earlier we used to have a physical testing era. We used to build prototypes, conduct expensive physical test, analyze the failure. Now then digital testing phase started. That is where we are at this moment. Run virtual simulations, iterate design rapidly in a software environment, and then go for a prototype, eventually for a release. But with AI, the intelligent systems do predict the performance before simulation even begins. So that is what is expected, or that is where the world, automotive design world, is moving. So critical decisions are made virtually long before physical prototypes exist. This fundamental shift has transformed how products move from concept to reality. So the paradigm shift is building, creating a physical prototype, conduct real world testing, identify design flaws, and go back to start. That used to be the earlier design cycle. With AI, you have design, so you create digital CAD model with intelligent design assistance. You simulate comprehensive virtual test across multiple scenarios. Now, AI comes where it refines the design based on simulation results automatically. Currently, it is an engineer who decides whether a design is perfect or not, and a lot of engineering sense goes into it. That is where AI comes into the picture, and move to the production with confidence and validated performance is what is happening now. So the modern industry doesn't design product first, they design digital prototype first. A physical manufacturing follows virtual validation is what is happening. So the evolution of simulation-driven design wasn't a choice. It's like everybody is using AI, and that's the very reason we are having this workshop on AI for simulation. Because if we don't use it, we are gonna miss the bus, and we may be irrelevant eventually. Now, why simulation is essential? So there is a huge pressure on us, time to market. So accelerated product cycles demand rapid iteration, validation. Traditional prototyping simply cannot keep the pace with market expectation. Then there is a cost involved in physical prototype. Building a testing physical prototype consumes enormous amount of resources. Multiple iterations can cost lakhs or crores, making digital validation economically very difficult. And there is an innovation demand expected. Have you seen latest Hyundai car which was just recently launched? I'm forgetting the name. Anybody remembers the name? Latest Hyundai car? I think Venue. Yeah, Venue. They launched it at 8.5 lakhs. Okay. And earlier they launched it about 6 to 8 months ago. That time it was, I think, 10.5 lakhs. And they have changed everything within 6 months, and did a lot of cost optimization and able to deliver the car to customers in 8.5 lakhs now. And then there is huge demand for the same car. So customers are expecting a new variation or new variant to be there. If there is an old variant, customer doesn't want to pay money for it. For example, we are using mobile phones, right? All of us are using mobile phones. Uh, After 2 or 3 years, we want to have a new mobile phone. And if somebody tells us that, okay, you have to pay this much money for the version which was built about 3 years ago, you will not be ready to pay. So that's where the customer demand is moving, and that's where time to market pressure has arrived. Now, there are three fundamental simulation methodologies. Most of us are, I think all of us are mechanical engineers, and most of you are familiar with the kind of analysis simulation technologies can perform. So one is, of course, finite element analysis. I need not to explain. You basically find out the stress and strain. Another is CFD, that is a computational fluid dynamics, where a fluid flow behavior, including air, water, and gas, uh, are studied and optimized from aerodynamics, cooling system perspective to find out the optimum shape, size. Then thermal analysis, that is heat transfer and temperature distribution throughout the component, and vital for managing thermal loads, preventing overheating, and ensuring reliable operations. Now, what are the leading industries in a simulation platform? I hope most of you must have heard about these names. So ANSYS, which is part of Synopsys now, is a leading software provided for CAE, CFD kind of a scenario. Then there is a Dassault, Abacus is their product. Then there is a Hexagone, that's where I work, which was MSC software earlier. And then there is a Cadence. So by the way, I don't know whether you guys know this, MSC software is used in Cadence Okay. So why AI is entering into the simulation? That's very important question that comes in mind. So traditional simulation workflow have reached to the critical point. We want even more faster results, even more faster iterations, even deeper design exploration than classical methods which are providing this. Okay. So what are the bottlenecks? Let's discuss about them. So we do have a manual meshing. To my knowledge, I haven't heard. I mean, there are softwares which were developed and which claimed that they are able to do automation, but I haven't really seen any software which does automation to the very complex geometry so far. So engineers are required to spend days creating and refining mesh geometries, require deep expertise and constant iteration to achieve acceptable quality. That's a problem. Then complex simulation can consume enormous computational resources. 6 to 8 hours to run a simple simulation is common. Then with simulation technology also, you can run maybe few iterations, not too much. I mean, you can run maybe, I don't know, 3, 4, 5, 8 iterations, but beyond that, it's very difficult. It becomes demanding, challenging, and at some point, manager says, okay, these are enough iterations. Let's go for prototype. And how many of you have struggled to give simulation projects because tool is not available, because ANSYS is not there, because Abacus is not there, because the required amount of licenses are not there. Okay. 1 second. Let me see if I can see the chat. So I have a question. How many of you struggle give simulation projects? If you guys are listening, do you hear me?
Yes, sir, we are hearing you, sir.
Okay, no problem.
And many times the struggles are always there while solving numericals or using CFD, meshing, and different applications like, right, sir?
Yeah. So many times we don't have required simulation software, we don't have required amount of tokens. In fact, most of the times we don't have good quality computers which will run the complex simulations, although we have big ideas. Yes or no? Okay, good. So now let's understand a difference between traditional approach and AI augmented approach. So traditional approach, 10 years ago, if you would have asked me, simulation was the thing. I mean, that's when I did my PhD about 10, 11 years ago, because that's when it was a hot cake. Let me put it this way. What could be a good example? Say somebody bought XQE 500 about 5, 6 years ago when it was launched. Everybody would have been, wow, amazing, you have got a XQE. But these days, even your neighbor would have XQE. So it's not, unique. It's not different. I mean, 10 years ago, if somebody would have had iPhone, we would say, wow, it's a great phone. But now every other chapri has an iPhone. Yeah. So that's the difference. So slow execution is a problem. Although as per us, it is quite fast. Then there are few design explorations which we can do. 5 to 10 variations are industry standard. Then there is a manual meshing. No matter how much we try to uh, automate meshing, but still we haven't achieved automated meshing for complex part. and it requires high computational cost, licenses, resources, servers. Yeah, with AI approach, you have instant predictions. The results are delivered within seconds, not in hours. You can do 1,000 variations just like that among the very brief design space. There is an automated meshing. AI handles geometry preparation automatically, and you can have a scalable insight. Okay, that is what you can do with AI approach. So from solving equations to predicting outcomes is where we are moving. Traditional simulation solves the complex physical equations first, and then every design iteration, those equations are resolved again and again. What AI works on, AI transforms this paradigm entirely by learning the pattern. What is AI? It simply learn the pattern, how the simulation is evolving with neural network and and instantly predict the outcome with few new design without solving equations. The key insight here is AI learns from historical simulation data. It recognizes the pattern in how design parameters influence the performance outcome. This is, learned knowledge enable near instant prediction. Is this idea clear how AI really works? If you have any question you would like to have me do little more discussions, do let me know. Okay, it seems it is clear. Let's move.
Participant can unmute yourself and you can directly interact with the resource person.
Can you please mute whomsoever was unmute? Okay. Industry use cases across mechanical, battery, and chip domains is what we are going to talk about, because most of you faculty members, you are working in this particular area when it comes to simulation technology. Either it's mechanical, either it is battery, because battery is a big boom. And if you are trying to secure your research future for next few years, I suggest you get into chip domains, because that's where a lot of innovation is happening. So from automotive components to the semiconductor design, AI powered simulation is transforming how engineers approach complex product development. So machine learning based automation is there. So traditional machine requires expert knowledge, hours of manual refinement, while AI learns from thousands of previous simulation, recognize the complex features like fillets, holes, thin wall, and automatically refines the critical region without coarsening anywhere else to balance the precision. So you have 90% of reduction in time, you have adaptive refinement, and you have consistent quality. This is what machine learning based automation can deliver. Then you can create surrogate models and reduce order models. This word is very important, reduce order models. If you want to get into the research of AI for simulation, my suggestion is do study or do read papers around reduce order models. Okay, what you are required to do, train once and predict instantly. So these are the surrogate models which act like a lightweight proxies for expensive simulation. You train a neural network of 1,000 simulation runs and then deploy this predicted outcomes in a milliseconds. Okay, so in a training phase, you may require 500 to 1,000 full simulation covering the entire design space. What are the various permutation combinations you may have? For example, a very simple example, you are trying to simulate, say, cantilever beam, and you are applying a load, and you know what is the amount of deformation, what is the amount of stress you are allowed to have on that cantilever, and you want thickness to get varied. So what do? You run those 500 to 1000 simulations first, feed that entire data to the neural network. It learns the relationship between input and output. And then whenever you need some other outcome by changing some other parameters, immediate prediction can be provided to you. That's how the AI work. Okay. Now you can use a genetic algorithms. What is genetic algorithms? You have a general or generative diverse design variation which is random. You evaluate which are surrogate models to score each design. You select and breed them, combine the test performance to create a new variation. You mutate and iterate those variation in order to achieve the convergence. Okay, so combined with surrogate model, engineer can evaluate thousands of design variation overnight. That's the possibility. Again, do study or do find some paper about what is surrogate model, and then you will understand more. You can use AI for defect prediction in manufacturing. So for porosity detection, for residual stress detection, for tooling optimization, you can use AI models. Okay, so predict casting defects from mold design and material flow simulation is possible. Identify regions which are prone to wrapping and cracking during the cooling can be studied. Adjust manufacturing parameters to eliminate predicted failure modes can also be studied with AI. Now you might have heard this word called digital twin. What is digital twin? Whatever your physical prototype is, a digital copy of that physical prototype is called as digital twin. What it does, the simulation layer provides a physics-based understanding while machine learning detects a stubble pattern behind it. So what it does, you have a physical machine. You don't record what is happening to the physical machine. You create a digital twin of that particular machine, run multiple simulation, provide a lot of input data, collect a lot of output data, and provide that all data to your machine learning model. And then eventually, whenever you want to predict something, this machine learning model will predict that for you. Okay, so you have a real time data, you have a predictive maintenance. For that, you can also use this digital twin approach. You want to study physical simulation, which predicts the behavior under certain conditions. You can use this, and you can also use for anomaly detection. That is, what are the potential failures that may happen in actual machine. Now moving to next, if you are looking for any new area of research studies, I strongly suggest get into battery applications. There's a message, please provide feedback, link of first session. Okay. So battery applications. So there is a thermal runaway and degradation prediction. That's the area, that's where a lot of funding is being provided. In electrical vehicles, battery safety and longevity is very important. So AI model can be trained on electromechanical and thermal simulation to this thermal runaway and long-term capacity degradation. So thermal runaway detection is monitor a cell temperature degrades and voltage pattern, current pattern, early warning signs of catastrophic failure. All that can be studied, okay, with the help of simulation. And you can also predict a degradation, like after 2 years, what would be the battery capacity? After 3 years, what would be the battery capacity? And so on and so forth. And different pattern, temperature history, electrochemical model, optimizing what is the charging strategy that will give you a better battery span can also be studied. So 20% of lifespan expansion can be possible, and you can have a more safe, reliable batteries that will not drain away during the event when you need them the most. Then another area is battery cooling optimization. That's where CFD plus machine learning is being utilized. So you simulate the coolant flow through battery packs while machine learning optimize the cooling channel geometry. So the geometry, cooling channel geometry is being optimized with the help of machine learning. This is also one of the kind of projects which a lot of researchers are right now working on. So engineer can explore thousands of channel configuration, uniform temperature distribution, pressure drop, manufacturing complexity. All those constraints can be applied to find out which is the most optimum practical channel that one should use to get most out of cooling optimization. So you have a CFD baseline that is simulate the existing cooling design to establish performance metrics. You have a parameters where you define. Sir, can you please mute the participant? Sir, can somebody please mute because there is a noise coming from the back.
Yeah, the participants, hello, participants are requested to mute your mic during the session, please.
So you have a defined, no, you have a defined design variable, channel wheel spacing, flow rate, inlet configuration, all that is your parameter space. Yeah, you can apply genetic algorithm or generalized algorithm to explore the design space using surrogate model. I again and again emphasize on this word. If you are new to AI, surrogate models is a keyword you need to search in the research paper or in books to understand how to model this space. And then you can validate and refine. Then one of the, how do I say this? So ANSYS has been acquired. I don't know whether you guys know this. To, if I'm not wrong, $33 billion. Okay, ANSYS valuation or ANSYS revenue was even less than 1 billion. Okay, try to understand this. And this is acquired company by Synopsys. Okay, which is into simulation. MSC Software, a small company acquired by Cadence, which is very big company at a very high cost. Again, a chip simulation company. What is happening is entire world is moving towards chip manufacturing and chip simulation. Those are the areas where a lot of funding, a lot of research, a lot of upcoming. So if you are looking for some new area where you want to learn and do research, get funding, this is the area you should look for. And in this area, some early research papers are published. That is where people have already started building machine learning models. I mean, I wouldn't be surprised that 10 years from today, we will not see any Abacus or ANSYS software. There would be an interface. That is where you are required to upload your geometry and simply write a prompt that these, say you are uploading a geometry of a table, simply write a prompt saying that 4 legs of the table are constrained in all the direction and the load of 100 kilonewton has been applied on the top surface of the table. Do let me know what are the stresses, strains and deformation of the table. That is where world is moving. Okay, and this is being also utilized for chip simulation technology. So what are the issues chip design have or chip simulation have is a hotspot, because there are some hotspots in the motherboard, and those get certain points in the motherboard gets heated more as compared to other points in the board, and that creates a deformation, and even a smallest deformation can lead to the failure in case of complex electronics design. when you're running thousands and thousands of simulations within seconds, you must somehow provide a technology to cooling strategy so that your heat sink is optimized. Design ideas you can for a chip design, there you which are in line with the fabrication technology have to be thought of. So that's where manufacturing engineers would come into the picture. So let's understand some real world impact case studies with the help of AI. So you have virtual crash testing and CFD. So Tesla combines the CFD and crash simulation to optimize aerodynamics and safety simultaneously. Earlier, we used to do CFD analysis separately and structural analysis separately. But what Tesla did, they combined together. And with AI power surrogate models, they are allowing, or this model is allowing them to rapidly iterate across various different variation, reducing the wind tunnel testing by 60% while improving the crash performance scores. So that's happening. This research paper is available. If you want, I can send it to you later on. Then Google is also using AI designed chips. So Google's TPU chips are particularly designed by reinforced learning algorithms that optimize the component placement. The AI explores the billions of layout permutation, discovering the configuration that human engineers cannot even consider. So this AI is helping them to design better. These industry leaders demonstrate the AI power simulation isn't experimental, but that's the need of an hour. Now, having a part of this FDP, I just would like your students to have certain modern engineering skills. So new kind of skills, what your student must possess in order to get an industrial job. So they must know simulation fundamentals, either if or both is good. They must understand what is fluid dynamics, what is thermal behavior, what is mesh generation, linear, non-linear, how actual solving happens. Second is they must understand bit of Python and machine learning basics. So how to write, and libraries like NumPy, Pandas, and TensorFlow should be known. They must also study bit of development. So GitHub documentation can be studied. So showcase the projects with clear documentation, version control, collaborative workflow. A well-maintained repository will showcase that they know how to build a machine learning model with the help of simulations to solve a real world problems. So you might wonder that earlier mechanical engineering degree was sufficient to get selected, but now everybody is asking, okay, you have mechanical engineering degree, but do you have any AI skills? So what's different? So AI engineers, they think in a systems. These engineers don't just operate software, but understand how components interact, how variables influence the outcome. I mean, they know that what is the input parameter which has the maximum effect on the output. For example, if I apply or if I increase the load by certain amount, what is the effect on the stress? They do understand. So they think in terms of systems and how to optimize the entire workflow rather than isolated tasks. And they experiment fast because they're combining simulation speed with AI-driven predictions. So they do the iteration fast, test multiple scenarios, deliver insights in hours instead of weeks. So that's what is expected in industry. So these are few top mechanical engineering project ideas I would like to suggest. So AI surrogate model for beam stress you can start with. If you're completely new to AI and how to use it, this is the project I strongly suggest you can start with. Train a neural network on FEA data, predict the cantilever beam stress pattern instantly, reducing the simulation time by 95%. It is tried, tested, available model. And afterwards, you simply WhatsApp me, and I should be in a position to provide you the entire PDF along with the supporting files you required for running this particular project. Then you can do a heat sink fin optimization. So CFD, somebody is from CFD, you can use CFD simulation with ML algorithms to discover optimum fill geometry that is best for maximum heat dissipation. Then you can use fatigue life prediction, a machine learning model that predicts the fatigue life cycle by providing material properties and loading conditions. You're not required to run end-to-end fatigue analysis simulation. That's where the world is moving, guys. Okay. Then drone propeller airflow. You can do a CFD analysis and optimization algorithm to enhance the propeller efficiency and reduce the noise emission. You can use a topology optimization with AI. Combine the generative design principles with AI to create lightweight structures for 3D manufacturing, because additive manufacturing is around the corner. I mean, I wouldn't be surprised in 5 years from now, traditional manufacturing will be completely stopped for at least 30 to 40% of components, and where the 3D manufacturing will take over. Do invest your interest into battery and electrical vehicles, because that's where the growth is happening. Every company in the world, every automotive company in the world is trying to build, or at least already built, electrical vehicles, and battery is their pain area. So battery degradation prediction is another machine learning kind of a project you can give it to your students. Thermal cooling optimization is another model which you can give it to your students. And if you are ambitious, you already know a bit of AI, you are already confident about your FEA and CFD skills, my suggestion is get into semiconductor and chip design project. Chip thermal modeling is an area where you can easily get funding and your students will easily get jobs. So this kind of a project, which is machine learning project to find out the pattern in a layer geometry, enabling early stage design optimization. You can reduce the thermal simulation by 80%. You can identify critical heat zones faster. You can optimize the cooling strategies. If you don't want to get into automotive, you don't want to get into other areas, you can also do AI-driven floor planning, where you can accelerate design cycles, improve performance metrics, and reduce the manual iteration. That's also possible. Now, I would like to give you a very simple 5-step execution framework. Identify the problem, run the physics-based model to generate comprehensive data set, create data which is clean and a structured manner. I mean, what are the various inputs you have given? What are the outputs you have achieved on a multiple levels? Then select a appropriate AI model to train those inputs and outputs. That black box have to be trained. If I give this input, this is the output. If I give this input, this is the output. Then deploy this model to check what is the output it is giving for given input, and then go on optimizing this model. These are the very simple 5 steps to get into AI. My suggestion is don't teach tools only, teach your students to solve problems. Encourage students to work on a real industry problem that develop a critical thinking and innovative capabilities. So that's all from my side. That's a scanner you can use to give a feedback about this particular session. I have 10 plus AI simulation project ideas, which have comprehensive project PDFs, step-by-step implementation guide along with the theoretical background. There is a data set which is already there, and you can use those projects immediately for your or to provide it to your students, which they can do as their final year engineering work. Yeah, so you can scan and provide your feedback. And once I have your number, I will provide you these PDFs and supported files. Yes, that's all from my side. Can you please confirm if you have access or you can scan? Anyone?
Yes, we can scan.
Let me know once the scanning is done. You provide your feedback, you provide your number, and I would be more than happy to provide you a zip file containing simulation project ideas along with PDFs, along with dataset, and I would be more than happy to guide you. Now we have a lot of time. If you have any questions, please feel free to ask the questions. Thank you, sir, for pasting the link here.
Participants, please ask question if you have any.
Yeah.
You can also put it into the chat box.
Yes. We have plenty of time. If you have any questions about only, say, particularly about your project, that also can be discussed on, or how to get started with AI, where things are moving. Yeah. This is a short link I've also pasted for you to provide a feedback. I think it is the same link, huh? Maybe. So people who will provide a feedback, those only will get a message from me, including all the zip files and everything. Can you please explain about simulation of metal casting process? By which software are we talking here? Metal casting. Procast. So in Procast, you select or you create a mold and then you try to find out what would the hotspot by providing or by having multiple locations in the mold. Is it how it works?
Yes, sir. Yes, sir. It works like that. Yes, sir.
Okay. So one of the biggest challenge here is how to find out where to put, I think, gate locations. Am I correct? because each gate
Yes, sir. The metal flow, where the metal flow is proper or not.
right. So in the simulation, right, what happens is you apply say one gate and then see what are the hotspot, how much time did it take, was there a metal shortage, was there a more porosity by simulation itself. Then you use a second or two gate location, then you use three gate location, then four, then five, so and so forth. You apply different permutation combinations for a particular system, and you have that input data, you have that output data, you provide that input data to output data to that machine learning model. Of course, you have to have bit of understanding about how all this really works. And then whenever you ask to that machine learning model, okay, give me a prediction, if I use three gates at this particular location, what will happen, and it will immediately provide you. That's how AI work. Have I answered
Yes,
your
sir.
question?
Yes, sir. Thank you, sir. Thank you. Nice, sir.
Dr. Patel, AI certainly can improve mesh generation. What is happening is, if this is the geometry, this is the kind of mesh I would like to have, and these are multiple steps to follow. So what we do is, because at the end of the day, what is a mesh generation software? It follows the human instructions, right? One second, let me
Yes, sir.
it follows the human uh, instructions, right? So if you have a sharp geometry, and then you provide that this is how the mesh generation have to be done. Do step one, step two, step three. Step one, step two, step three. Step one, step two, step three. Like that, and now the final mesh is built. Now, if you have any similar kind of a corner coming, please follow this particular set of instructions which I have done earlier. If you have a small hole, these are the set of instructions you should be following. If you have a fillet, these are the instructions you should be following. That's how, improvisation on a mesh generation can be done. Is it clear?
Yes,
Have I
sir.
answered?
Clear, sir. Clear, sir.
Okay, good. Now, role of surrogate model, Jyoti ma'am, I think it's very difficult to explain in a very short manner. Surrogate model is a kind of a demo model for you to understand. Okay, because in the real model, it may be a bit different. So, okay, most of mechanical engineers, we use dumbbells, but in real life, we never use dumbbells, right? We
Right,
try
sir.
to apply load, we try to study stress. Imagine that's kind of a surrogate model. Surrogated model is a model on which the training is happening, which is bit kind of a representative model of a real life scenario that might be happening. That's the best way I can explain what is surrogate model.
Okay, sir. Thank you.
Yeah. Any other questions? AI help for meshing in analysis. I think I've just addressed that, right? If you have corners and you simply record how did I mesh it, and then ask AI that please follow the instructions, the same instructions whenever you come across similar kind of a fillet, kind of a corner. That's how the meshing can be done faster. Have I answered that, Vilas sir? Vilas Patil sir? Okay.
Yes, sir. Definitely. I think you have answered the question. That was uh, meshing, regarding the meshing. Thank you, sir.
Yeah, but I would say still it is evolving, still it not fully matured. But I think your students should always try to utilize those ideas. Okay, so don't produce
Yes.
students who knows the softwares produce engineers who solve the problems, is what my message is. Needs.
Definitely, sir.
Sir,
Yeah,
can I ask one question?
please go ahead. We have time.
Sir, while designing the mold in castings, can we simulate that the effect of runner or riser length for optimization?
Absolutely, yes. A lot of softwares are already doing it.
Yeah,
Already,
but
yeah.
AI can give an optimum solution about that particular length of runner and riser.
Yes, but for AI, it must first understand what is the effect of what. So how
Yeah,
AI works in a simple words, let me explain you. Okay, let me try to explain you in a simplest possible manner how AI works. You to the computer you give or you explain how the addition work. So you explain 1 plus 2, 3. Okay, you
yeah.
explain that.
Yes, sir.
Then you do 1 plus 4 and you say 5. 1 plus 4, you 1 plus 5, you say 6. Now it has learned how to do addition. Okay.
Is it?
Yeah. Now you have given some input. You have given 1, 2, 3, 4, 5, 6, and you are given some inputs, 1 plus 2, and you have given some outputs that it is coming out to be 5. It doesn't know addition. Okay. Just imagine it doesn't know the operation addition.
Okay,
You
sir.
simply give input 1 plus 4 as an input and 5
Yeah.
as output. 1 plus
Yes.
5 and 6 as an output. And there's a black box. Doesn't
Yes.
know
Yes.
what is happening inside. Okay. A huge amount of inputs are given, huge amount of outputs are given by doing the real life simulations,
Yes.
like numerical simulation, because that's where the power of simulation is. Yeah, and that's why the valuation of company which is making revenue of 1 billion has been sold to 33 billion. Give one more. Now plus 1, 2, 1 plus
Yeah.
3, 4, right? Then you give big kind of inputs and then ask machine learner to predict and then say, no, no, you're off by 20%. Please correct yourself.
Yeah.
You're off by 30%. Please correct yourself. That's a fine tuning. And once the model is ready, then afterwards, whatever input you give, it will give you accurate results.
Just like a convergence of solution.
Yes.
But for giving an input to the system, we need to be an practical example datas. Lot many datas is required for that.
No,
So
not really. Any research paper you pick up, any research paper. I'm a researcher myself. You are a researcher yourself.
yeah,
Uh,
know that.
why
But
what we do is we take experimental data and we validate that experimental data with simulation model, say one simulation model or two simulation models, and then remaining permutation combinations we simply vary and create a results, right?
okay, sir.
you
Okay.
you see the
Thanks a lot,
point.
sir.
First
Yes.
you validate one base model and then take it to the next level.
Okay, sir. Okay. Thank you, sir.
So please stay in touch. I provide sessions on resume writing, interview techniques, AI in resume writing, LinkedIn optimization, career progressions, AI for teachers, jobs in mechanical engineering, jobs in non-IT field, or any other AI related topic. That's my number, and you can WhatsApp me. Okay, do we have any other questions? No, thank you. Okay, thank you very much. Bye. Sir, can we close?
Okay, sir. Yes, sir. Please 1 minute. I'm
Yeah.
Dr. Hullas Tonde from the Sriyash College of Engineering and Technology.
Okay,
So
sir.
from now, I'm hosting this event.
Okay.
So this is the time for the vote of thanks, sir.
Okay.
So I extend my heartiest. I'm thankful to you, sir. First of all, I'm thankful to you that you brought a schedule time from your busiest schedule, sir. So I would like to thank also the AICTE and Atal Academy for their funding support and for approval of our proposal. That's why we are organizing this FDP for different faculty members from across the country.